Hello, everybody. I hope you are healthy and happy in your homes. I know this is going to be tough. We are having tough times nowadays, but it's going to pass and we are going to meet again in the near future. In order to make you and keep you safe, we are doing our best to provide you online courses. And today I'm going to teach you a little about matrix algebra. So without wasting your time, let's get into it. Yeah, matrices. Matrix, the definition of the matrix, we can simply say that matrix is an arrangement of numbers. So let's imagine that you are going to a bakery and there are a lot of people there. One of the natural ways to do is that we create a line, right? So we create a line and we put the people on the line. Why? Because in this case we can call them really easily. The first person we can say, for example, the second person, the third person, we can call them without knowing their names. So this is the property of the matrix. You have a huge amount of numbers and data and you want to arrange them because you want to call them later. Okay? So matrix is a simple arrangement of numbers. We normally call the matrices by capital letters like A, B, or C. And then we put two brackets, as you know, and then we put our numbers there. For example, 1, -1, 2, 3, 4, and 0. So this is a matrix A, and it has 6 elements. So the numbers inside these two brackets are the elements of the matrix. The 1, the -1, 2, these are the elements of the matrix. And important things here that we need to learn is the size or the order of a matrix. How we say what is the size and order of a matrix? Let's look at this matrix, for example, A. It has one row in here and one row in here. Okay, this is a row, it's a vertical. It's a horizontal arrangement of numbers. So this is row 1, row 2. So how many rows? This has 2. So A has 2 row. How many columns does it has? 1 here. What is a column? Column is the vertical arrangement of numbers. This has 3. So it has, the column has 3. So we say that A, the size of A, the size of matrix A is equal to 2 by 3, where 2 means the row, number of row, and 3 means number of columns. Now, how we can call the elements of a matrix. Let's call another matrix like B is equal to 1, 2, 3, 4. Right? So how do we call the elements of a matrix? It's very simple. For example, we are going to call the element 3. How do we call it? We put the name of the matrix is B, but the capital we put the small letter. And then we say that in which row it is. It's this first row and this is the second row. We put a 2 here, which indicates the row, and the column. Which column is this? This is the first column, and we put 1. So this is B21, means this number, this element is placed on the second row and first column. So on the other hand, we called B, I, and J the element of the matrix, where the I shows the row number and J means the column number. That's simple. So let's give an example about this one. Let's consider the matrix C is equal to 1, 2, -1, 0, 3, 6, 7, 1, 2. And we are asked to provide the C3, 2. So what is C32? The C32 means the tree. The tree, it shows the row number. So let's look at the matrix. This is the first row, this is the second, and this is the third. So we are talking about this row. And which column? The second column. So this is the first column, this is the second column. So we are talking about these columns. So what is the common number between these two curves? Is 1. So the answer is 1. That simple. If your matrix is just a single column or a single row, we call them vectors. For example, A can be 1, 2, 3, 4, or B can be 2, 1, 2, 3. Right? These are just a single row or a single column. So we call the A as a row vector, and we call the B as the column vector. Now the question is that can we do addition and subtractions for the matrices as we do for the numbers? Yeah, we can do. It's simple. How? How do we say 2? In the numbers we say 2 plus 3 is equal to 5. Right? Actually, the numbers are also matrices. Now, how? Because they are single column, single row. Let's say that I can write it like this. 2 plus 3 is equal to 5. So these are matrices, 1 by 1 matrices, right? Because they have one row and one column. So the numbers are also matrix. And they are 1 by 1 matrices, but we call them as the numbers. Now, if we have the definitions for the matrix summations, for the number summation, of course we have it for the matrices as well. How? Let's say I have matrix A, 1, 1, 2, 2, and matrix B, minus 1, 0, 3, 4. Can I add A plus B? Yeah, it's simple. A plus B means you just sum each element together. Like I take 1, which is the 1, 1 element with the 1, 1 element of the matrix B, and I sum them up. 0. I take the 1, 2 element of matrix A and the 2 element of this one and sum them up. It would be 1. And then here I take 2 with the same element of 3. It's going to be 5. And then we take 2 with 4 and sum them up. It's 6. Right? So the definition for the A plus B is possible. But I guess you understand that if you want to add two matrices together, there should be conditions. The matrices should be from the same order. I mean, if the A is an m by n matrix, m by n, this is the size of the matrix A, the matrix B must be also m by n if you are going to do the adding, right? So the matrices should be from the same size. This is also the same for the subtractions. There should be the same size as the summation. Now there is two important properties in summation. In the numbers, we know that 1 plus 2 is equal to 2 plus 1. We call this property commutative property. It means you can change the places in the summation, right? Is it the same in the matrix? A plus 1, B is equal to B plus A. Yeah, the same we have. So the matrix summation or addition is commutative. Okay, don't forget. Now we had another also property in the numbers. We could say 1 plus 2 plus 3 is equal to, is equal to 1 plus 2 plus 3, right? It's the same. So in the matrix summation, in the matrix also summation, we have the same. We call this matrix addition is associative. So A plus B in the parenthesis plus C is equal to the same as A plus B plus C. Right? So the matrix addition is also associative. Okay, cool. Now let me introduce a very cool properties of matrices. We have a matrix we call transposition property. Transposition operation. Transposition. What is transpositions? It's very simple. Let's say we have a matrix A, 1, 2, 3, 4. The transpose of matrix A, which we can call it with the prime, or you can call it with the T at the power, is equal to, you change the place of the rows and columns. So, you change the columns and rows. How we can write? The simple way is to, for example, the matrix A is, this is the first column. You get the first column and write it as the first row. This is the first row, and I write it as the first column. 1, 2. I take the second row of the matrix and I write it as the second column. 3, 4. Now, there you have it. We have the transpose of matrix A. 1, 3, 2, 4 is the transpose of matrix A. Now, let's consider that if you have a vector matrix, let's say we have W is equal to 1, 2, 1, minus 1. So this is a row vector. So what is going to be the transpose of this matrix? It's going to be a column, right? Because there is just one. So it seems that I just need to take this one, this row, and write it as the column. 1, 2, 1, minus 1. Right? Very easy. Okay? So transposing a row vector turns it into a column vector. And transposing a column vector, of course, turns it into a row vector. Now, there is a cool definition here for the matrices. We have a definition called A-square matrix. What is A-square matrix? An A-square matrix is the matrix that it has the same row as the same column. So the number of column and row are the same, like 2 by 2, 3 by 3, 4 by 4, and so on. Like 1, 2, 4, 1. A is an A-square matrix. Or a 3 by 3, it can be 1, 1, 1, 2, 2, 2, 3, 3, 3, for example. The matrix B is also right now an A-square matrix because it has 3 rows and 3 columns. They are the same, right? So in the transpositions we have a definitions which is cool. Let's go it. So an A-square matrix, if you take the transpose of an A-square matrix, and this transpose is equal to the matrix itself, we call this symmetric matrix. We say that the matrix A is symmetric. Let's say, for example, I want to give you an example of this one. Let's say B is equal to 1, 3, and 4, 4. So now what is the transpose of matrix B? I take the first row, write it as the column. The second row, write it as the column. Wow, you see? The B prime is the same as the B. So the B matrix, we called it a symmetric matrix. Now there is another cool property here. if you take a transpose of a matrix and then take the transpose of the transpose matrix, we should get the A. It seems obvious, but there's proof for that, okay? I don't go over the proofs, but I'm just introducing the properties here too. Okay, this is cool. Another one, if you multiply a matrix with a scalar k, for example, and then take the transpose, the result is going to be the k times the transpose of the matrix. There won't be any change, right? Another cool definition is that these are very obvious. It seems obvious, but there is proof for them. Mathematical proof. So now the other properties is, sorry, if you add two matrices A and B and then take the transpose, guess what? This transpose is going to go to each of them. So it's going to be the A prime plus B prime, right? That cool. So we say that the transposition is also commutative property. Now, cool. So far so good, right? Elements, basic things, fundamentals. Now let's go to the another property. So for the numbers, now we look at the addition and subtractions. Now we need to look at the multiplications. Can we define multiplication for the matrices? Yeah, of course. First, n number multiplications. If you have a matrix A, let's say 1, 1, 2, 2, you can multiply it with a number like 3A is equal simply, how do we do it? You just multiply each element of the matrix by this multiplying factor. 3 times 1, 3, 3, 6, 6. Right? That's simple. Now, you may ask, can we multiply the matrix? Two matrices, can we multiply them? Yeah, of course. Let's say if you have matrix A and if you have matrix B, can we define A times B? Yeah, you can do that. But how? There are some conditions, and we're going to go over it. First, for the two matrix M, A and B, let's consider if the A times B is going to be, if we are going to find the matrix C, there is a condition that needs to be satisfied. First, if matrix A is an M by N matrix, then, and the B is a matrix of the K times L matrix, then there is a must condition that should be satisfied. N should be equal to K. If the A times B is going to be definable, okay? If we are going to define the A times B, the N should be the same as the K. Let's write it like this. So, if we say that A times B is equal to C, A is an M by N order, and I know the B should be N by K, for example. Let's say I told you these two should be the same for the multiplications. So now the question is, what is the size of the matrix C? It's going to take the M and K in here. It's going to be M times K, right? So we know now we know the condition for the multiplication of matrices. We know that the resultant matrix, what is the size, the order of the resultant matrix. But now there is a question, how we can find the matrix C. I will tell you with an example. Let's say the A is 1, 2, 3, 4, 5, 6, and B is, so B should be 1. This is a 2 by 3, right? So if I'm going to define the A times B, the matrix B should have 3 should have, look at this one, 3. This is the should be the number of the rows of B. So the matrix B should have 3 rows. So it's gonna be 1 rows in here and 1 rows in here. Okay. So let's say it has also 1, 2, 1, 3, 1, minus 1. Okay, this is the matrix B. So this matrix is a 3 by 2 matrix. Now, I know that A times B is C. What is the size of C? It's simple. You take the first one and take the last one. So it's going to be 2 by 2 matrix, right? Cool. But how we can calculate it? How we can calculate the A times B? Okay, I want to tell you. So I know the matrix C is, it has 4 elements, right? It's a 2 by 2 matrix, so it's going to be the form like this. So this one is going to be the 1 by 1. This is the 1 by 1 element. 1 by 2, 2 by 1, and 2 by 2, right? Now, in order to calculate the C11, we will do like this. The first number is 1. We take the first number is 1, and the first number is we say that this is the number of row. This is the row number. So we take the row of the first matrix. The first matrix is matrix A. So the first row of the matrix is going to be this one. I take it and put it here. So it's 1, 2, 3. And I take the second one is the 1 also. So I take this from the second matrix, the first column. So this is going to be the column of the matrix. First column. So this is the column, right? I put it here. As for example, it's going to, let's say it's 2, 2, 1. Right? So now you need to multiply these two columns. How? It's an inner product. You know inner product for the vectors? It's simple. We do it like this. Look. We say that 1, 2, 3 multiply 2, 2, 1. We do it like this. Sorry. We say that 1 times, we say 1 times 2. We write it here. 1 times 2. And then we say 2 times 2 plus 2 times 2 plus, and the last one, 3 times 1. What is the answer? It's 2 plus 4 plus 3. That's going to be 9. So now I know the C11 is 9. And I can do the same for C21, C12, and C22. So it's going to be simple multiplications. Let's do a simple example. Let's say I have a matrix A is equal to 1, 1, 2, 2. And I have matrix B is equal to 0, 1, 1, 2. Now how to calculate the A times B? So I know this is A is the 2 by 2 matrix. This is also 2 by 2. So the matrix A times B is going to be 2 by 2, right? Okay, how the first element, we do it like this. The first element is going to be like this. We take the first row and the first column. Multiply and sum. 1 multiplied by 0 plus 1 multiplied by 1. So it's going to be 1. We go to the next element. Here, we take the first column, the row again, but the second column of the matrix B. Now again, multiply and sum. 1 times 1 is 1. 1 times 2 is 2. So it's going to be 3. The next element, so we are going to the second row. So I go to the second row of matrix A. But we are in the first column of matrix right now in here. So I go to the first column, right? Again, multiply. 2 multiplied by 0 is 0. 2 multiplied by 1 is 2. And then take this one and the second one. 2 multiplied by 1 is 2, right? Is 2. And 2 multiplied by 2 is 4. So this is the matrix A times B, right? Cool. Now let's go to some properties we have for the matrices. The first one. The matrix multiplication is not commutative. It means A times B is not equal to B times A. So it's not like a number. In number, 1 times 2 or 2 times 3 is equal to 3 times 2. But in the matrix space, no. A times B is not equal to B times A. Second one, matrix multiplication is distributive. What does it mean? It means A times B plus C is equal to, as we know, A times B plus A times C, right? Is distributive. It's distributed into the paragraph. The third property is matrix multiplication is associative. It means A times B times C is equal to A times B times C. I mean, you can change the paragraph, okay? The parenthesis. So you can change the parenthesis, right? You can take it from here and put it over here. So it's associative, right? It's just like the normal numbers. Now, there is another important property. If you define matrix A times B, and then you transpose this matrix, what are we going to get? Guess what? It's going to be B transpose times A transpose. Very interesting, right? So don't forget, it's A times B transpose is equal to B transpose A transpose. So transpose seems that it just changed everything. It just inverse everything, okay? Change the place, okay? Don't forget that one. Now the other property is that as in the real numbers we have the power. So 2 to the power of 2, 3 to the power of 4, for example. In the matrices we also have the same. We can say matrix A to the power of 2. But what does it mean? This means A times A. Okay? Or we can say A to the power of 3, which is A times A times A. Right? But is it something we can define the A square or A cube for the matrices? There is condition. What? Let's say the matrix A needs to be square. So if you want to define the power for the matrix, the A should be square matrix. Don't forget this one. If it is a rectangular matrix, you cannot do the summation, the multiplications. Okay? Okay, cool. Now we're going to go to some cool matrices. We have some special matrices and they have some special properties. One, as in the numbers we have, for example, 1 is in special numbers, right? Why? Because if you multiply 1 by any number, it's going to be the number itself. So it's going to change anything in the number. Okay? In the matrix space, do we have such a matrix? If I multiply a matrix with that matrix, I'm going to get the same matrix. Yeah, we have, and we call it identity matrix. We call it identity matrix, okay? We show it with then a capital I, and we say that if you multiply the I with any matrix, you're going to get the same. So what is the matrix I? It's a diagonal matrix. What does it mean, a diagonal matrix? What is a diagonal? A diagonal is the elements lie on this. It's like a diameter of the square, right? It's defined for the square matrices, and it's the numbers lie on the diameter. So the diagonal is the biggest diameter in the matrix. If you have a 3 by 3 matrix, for example, so the diagonal be all 1 and the other numbers is going to be 0. So this is the diagonal of this matrix. So in the identity matrix, the diagonal of the matrix is 1 and the rest of the elements are equal to 0. And the properties are clear, just like the one in numbers. If you multiply I with I, it's the same by I times A, and it's equal to A. No changes, okay? It's cool, right? Yeah. So right now we know the diagonal matrices, and so you learn the diagonal matrix. What is a diagonal matrix? Diagonal, we said that all the elements except the diagonal elements are 0, right? I hope you learn a lot here. So I guess it's gonna be enough for the first part of this algebra, matrix algebra, and I will prepare you a second video on the rest of the analysis that we are gonna have on the determinants and the inverse matrices and the system of equations. I will prepare a video for that one and share with you soon. Take care and see you soon.